Hi, and in today's video we are going to be looking at rates of reaction and some of the factors that impact rate of reaction. So in another video I go through calculating rate of reaction. This one is the first of two videos about the factors of that affect rate of reaction. So first of all, the first thing that's important is to look at this collision diagram. Because whenever there is a reaction, what happens is two particles collide and react together. Now, for particles to collide, you have to have the right energy, and that is called the activation energy. So that is the energy required for a reaction to happen. So if this particle here that's going towards our reacting particle, the grey circles in the middle, goes with a lower energy than the activation energy, it'll simply bounce off it. But if it goes towards it with lots and lots of energy, any energy that's above that activation energy, it will hit, and like you can see here, there's a reaction happening and the particles collide. So the particles collide together, and that means that a reaction has happened. So it needs to be either on the activation energy or above the activation energy for the particles to collide successfully for the reaction to happen. Now, the activation energy is different depending on the reaction that you're looking at. Depending on the reaction. So different reactions have those different required energies for the reaction to start. So, just a recovery. The particles have to have a certain amount of energy. This certain amount of energy is called the activation energy. If it has got that amount of energy or more, when it moves towards the reacting particles, collides, and then a new product is formed. So that's the first little really important bit, which is about activation energy. And now we're going to be looking at temperature. So what effect does temperature have on the rate of reaction? So how quickly something reacts? Well, based on the fact that we said activation energy needs to be met, it's quite important. So temperature is different amounts of energy. So the higher the temperature, the more energy the particles have got. So the more likely that they'll have either got to the activation energy or above the activation energy. So that's the first point. The first point is the higher the temperature, the closer to the activation energy, the more likely the particles will collide. The other thing to think about is that hotter particles move more quickly. So those particles are moving more quickly around the container or whatever the reaction's happening in. If those particles are moving more quickly, which you can see in the diagrams here, those lines are showing movement. These ones here are moving more. So if they got more energy because they're a higher temperature, those particles are moving more, they're more likely to hit any reacting particles. So if I said this was the reacting particle and these have more energy, they're more likely to hit the other particle and form a product. So there's 2 points for temperature. The hotter the particles are, the more likely they are going to be able to reach that activation energy. And also, if they are hotter, the particles move more quickly, meaning that those particles are able to collide and have a reaction form. The final factor I'm going to go through in this video, before going on to the next one another time, is surface area. So surface area can either be really low, where it's here, where they're all together, and you can only react on the outside part. So if I just get a highlighter, you can only react with the particles. Let's make it a little bit smaller. You can only react with the particles on the outside of those bits there. So there's only a tiny bit of area that the reacting particle can hit. Whereas if we're here, the particles can hit all around there and all around there. So there's lots of space for them to hit and react with each other. Unlike in the first diagram where there was just that 3 lines where the particles can hit, collide and have a reaction. So bigger surface area means a quicker rate of reaction because there's more areas to react with. So it will happen quicker. So the quicker that, the more area that there is for the reacting particles to hit off each other, the quicker they're going to react because that's more surface area there. So just a review of the lesson. First of all, activation energy, really important because if you've not reached it, the particles are going to simply bounce off each other. As soon as you've got enough energy for that activation energy, the particles will collide and a product is formed. So temperature is important because it needs to reach that activation energy, but also higher temperature means the particles are moving around that container quicker, so they're more likely to hit each other and collide successfully. And a bigger surface area means there's more spaces for those particles to hit off each other and react successfully. Like I said, there's going to be another video on the final factors of rate of reaction. I've just split them up so that we're not bombarding you with information in one video.